So figure 8.1 shows a battery with a resistor connected across the terminal. The electromotive force or EMF is 6 volt. So this EMF is 6 volt because the only component which is connected is a resistor. So resistor will have a potential difference of 6 volts as well. The battery causes 90 coulomb of a charge to flow through a circuit in 45 seconds. So we know the charge is denoted by Q and the time is T. In the first part, we have to calculate the current. So the formula to calculate the current is charge divided by time. So current is denoted by I, charge is denoted by Q and time is T. So I is equals to Q by T. So Q is equals to 90 and the time is 45. So 90 divided by 45. So the current will be 2 ampere. As the unit of the current is ampere, so it will be 2 ampere. The next part we need the resistance. So the formula which relate the resistance, voltage and current R is equals to V divided by I. So V is a voltage that is given in the first part, 6 volts. And the current we calculated in A1, that is 2, so 6 divided by 2, that's equal to 3. And the unit of the resistance is ohm, so the resistance is 3 ohms. The electrical energy, the energy is power multiplied by time, or it is a product of voltage into current into time, or VIT. So V is a voltage which is 6, I is a current 2, and time is 45. So 6 multiplied by 2, that is 12, and then it is 12 multiplied by 45, which is equals to 540 joules. So that is how much energy being transferred in 45 seconds. Is it clear, this question? Then part B, what is meant by the electromotive force of a battery? So EMF of the battery, the standard definition, it is work done on unit charge when chemical energy changes to electrical energy. So this is standard definition, how much work is done on a unit charge to move the charge around a closed circuit. So work done on unit charge to move the charge around a closed circuit when the chemical energy converted into electrical energy. They have to learn this definition. Next, figure 8.1 shows a 240 volt AC main circuit to which the number of appliances are connected. As you can see, all the appliances are connected in parallel. So if this is a supply voltage 240, the fan will receive 240, refrigerator will also receive 240 volts, and each lamp will also receive 240 volts. So because they are all connected in parallel, so they will receive the same voltage. Then the question is calculate the power supplied to the circuit. So to know the power supplied to the circuit, we will just add them. So this is 1.2 kilowatt. The power for refrigerator, it is 200 watt. For the lamp, each lamp is 60 watt. So what is the total power? 1.2 kilowatt means 1200 plus the power of the refrigerator, which is 200, plus the power of each lamp. One lamp is 60, there are two lamps, so 60 plus 60. So we will add 1200 plus 200 plus 60 plus 60, so the total power will be 1520 watts. That's the total power of this circuit. The appliances are connected in parallel. What is meant by connected in parallel means? Connected in parallel means like separate connection for each appliance, or each appliance will receive same voltage. Then two advantages of connecting them in parallel rather than in series. So number one, they will work independently. And number two, they will have the same voltage. And here you can also mention connecting in parallel. Each appliance receives the same voltage, or separate connection for each appliance. So this is a definition how we explain the parallel circuit. The next part, the current in refrigerator. So how to know or how to measure the current in refrigerator? So we have, because it's 240, the refrigerator will also receive 240 volts. So we have the voltage and we have the power. The formula which relate power, voltage and current, we have P is equals to VI. So power is equals to voltage multiplied by current. The power of the refrigerator in the question, that is 200, and the voltage is 240. So P, the power is 200, equal voltage is 240, and the current is I. So 240 is multiplied, other side will be divided, so it will be 200 divided by 240. So 200 divided by 240, that's equal to 0.83. So the current in the refrigerator is 0.83 ampere. The energy used by fan in 3 hours. So energy is power multiplied by time. The power of the fan, it's given in the question that fan is 1200 watt, because 1.2 kilowatt means 1200, multiplied by time is 3 hour, but time should always be in seconds, so we have to convert this 3 hour into second. So it will be 30 multiplied by 60, sorry, 3 multiplied by 60, so it will convert into minute, and then further multiplied by 60, so it will convert into second. So 3 multiplied by 60 multiplied by 60, that is 10,800, and times the 1200, so it will be 12.9 into 10 to the power 1, 2, 3, 4, 5, 6 joules. That's a total energy consumed in 3 hours. The resistance, so we have the formula V is equals to IR. So R is equals to V divided by I. So V is a voltage which is 240. But we don't know I here because the current in each lamp is not known. So first we have to find the current. So how to find the current? Again, we will use a formula P is equals to VI. The power of each lamp is 60 and the voltage across each lamp is 240. So it will be 260 divided by 240, that will give us the current. So 60 divided by 240, that is 0.25. So the current in each lamp is quarter, 0.25 ampere. So now we know the current, which is 0.25. So 240 divided by 0.25, which is equals to 960 ohms. So this is how we get the resistance of this each filament bulb. Another question, figure 8.1 shows an electrical circuit. The resistance of the lamp is 4 ohm. So if this lamp is 4 ohm, this resistor, fixed resistor, is also 4 ohm. The lamp is rated 6 volts, so voltage across the lamp is 6 and its power is 9. Calculate the current. So we have the formula P is equals to VI. Power is voltage multiplied by current. P is a power which is 9. V is a voltage 6 and I is a current. So it will be 9 divided by 6 is equals to I. So 9 divided by 6 is equals to 1.5. So 1.5 ampere is a current. And because you can see they're all connected in series, like there is only one way for the charges to flow. So if 1.5 ampere is passing through or flowing through the lamp, the same 1.5 ampere is coming from the battery, and that same amount of current is flowing through each component. Because there's only one way for the charges to flow, it means this is a series combination. And whenever we have a series combination, the resistance, the current in series component is same. The sliding contact, like this is a movable part, it is moved to A. Calculate the total circuit resistance. So if we want to calculate the total circuit resistance, we already know the lamp is 4 ohm. So lamp is 4 ohm, resistor is 4 ohm, and they are connected in series. So whenever two or more component are connected in series, to find the combined resistance, what we do, we add them. So 4 ohm is a resistance of a lamp and 4 ohm is a resistance of a resistor. So when we add them, it will be 8 ohm. Then the potential across the 4 ohm resistor. How to get the potential across 4 ohm resistor? As we already calculated the current in the previous part, that the current in the lamp is 1.5 ampere. And because the lamp and this resistor are connected in series, so they will have the same current, 1.5 ampere. So we have the current and we have the resistance. So we can use a formula V is equals to IR, where I is a current 1.5 and R is a resistance 4. So 1.5 into 4, that is 6 volt. So what is the voltage across the fixed resistor that will receive the same voltage, equal to 6 volts. Then the sliding contact is moved from A to B. So right now the sliding contact is at A, but now it is moved to B. So if we move this sliding contact to B, now this wire is also having the resistance. So sliding contact is moved from A to B. So as a result, what happened? So this wire will have now resistance. The fixed resistor is also already having a resistance and lamp is also having a resistance. So now this part, before that, when it was at A, the wire was not having any resistance, but now wire is also used. So what will happen to the brightness of the lamp? The brightness of the lamp will decrease. Why? Because some of the voltage will drop across this wire, or some of the energy consumed within this wire. So remaining energy or small amount of energy will transfer to the lamp or a bulb. So the brightness of the lamp will decrease. So describe a change that occur in the brightness of the lamp. So answer, it will decrease. And what is the reason for that? Explain your answer. The voltage will drop across the wire. So small voltage or potential difference across the lamp. So in the beginning, because the resistor, that this wire, as I mentioned in the beginning, it was at position A. So when this sliding contact was at position A, sliding contact means like it's a movable part. So when the sliding contact is at position A, the charges, when they are moving through, so from A they are going to the resistor and then they are going to the lamp. So this part was not having any resistance, like this is not contributing. And if it is a 12 volt supply, so 6 volt is here and remaining 6 volt was across the lamp. But when we move the sliding contact to position B, now a fixed resistor is also having, like this wire is also having some resistance. So now the charges have to pass through this wire, which is having a resistance, then a resistor, and then the lamp. So as a result, what happened, if this is a 12 volt, maybe like 3 volts drop here, or maybe like 4 volts drop here, remaining 4 volt drop here, and 4 volt drop here. So the voltage across the lamp decreases. That's why the brightness of the lamp will decrease. Is it clear, this part, that why the brightness of the lamp decreases as we move the sliding contact or movable part from A to B? Then a 1 meter wire between A and B has a resistance of 2 ohm. Calculate the resistance between A and B when a 1 meter is replaced by 2 meter. So we know resistance and length are directly proportional. If it was 1 meter and it was having a resistance of 2 ohm. Now we have 2 meters, so it means the length is double. If the length is double, the resistance will also be double. So if 1 meter is having a resistance of 2 ohm, 2 meter will have a resistance of 4 ohm. So here the resistance will be 4 ohms. Then a 1 meter wire is replaced by 1 meter of same material but half cross sectional area. So what is the relation between resistance and cross sectional area? They are inversely proportional. Like if we decrease the cross sectional area, the resistance will increase. So if the cross sectional area is half, it means cross sectional area is divided by 2. So what will happen to resistance? It will be multiplied by 2. So if originally it was having a resistance of 2 ohm, then 2 multiplied by 2, now the new resistance will be 4 ohm as well. So as you decrease the cross sectional area, resistance increase. As you increase the length, the resistance will also increase. So with length, resistance is directly proportional, and with area, it is inversely proportional. Figure 8.1 shows a part of a low voltage lightning circuit containing 5 identical lamps. So 5 lamps are there which are identical. By addition of the component as necessary, complete the circuit, the total current of a supply can be measured. So if we want to measure a total current, what we should do? We should connect an ammeter. So we'll connect an ammeter before or after the supply. So that is done. The brightness of the lamp E can only be varied. So if we want to change the brightness of the lamp, what we connect, it should be a variable resistor, because a variable resistor, its resistance can change, so the voltage can change, and due to change in voltage, the brightness will change. Lamp C and D may be switched on and off. So means lamp C and D should have a common switch. So how to make a common switch? So we'll join by a wire and then we connect a switch. So this is a common switch for lamp C and D. Now we have to just complete the circuit. So we completed the circuit. The first part was that the total current of a supply to be measured. So if you want to measure the total current, we should have ammeter next to the supply. If you want to change the brightness of the lamp, so we should have a variable resistor, because a variable resistor can change its resistance. So the brightness of the lamp will vary. And lamp C and D may be switched on and off. So if you want to switch on and off these lamps, so means we need a common switch. That's why we connect them by a single wire and then one switch. So when this switch is closed, the lamp C and D will work. If it is open, the lamp C and D won't work. Now all 5 lamps are marked. So all the 5 lamps are marked 12 volt. So this is a voltage 12 volt and 36 watt. Assume that the resistance of each lamp is the same fixed value. Now the current in one lamp when it is at normal brightness. So we have the power, we have the voltage, we need a current. So formula is P is equals to VI. So power is 36, V is the voltage 12, and I is the current. So 12 is multiplied with current, other side it will be divided, so it will be 36 divided by 12. So 36 divided by 12, that's equal to 3 ampere. The resistance of one lamp. So to get the resistance, we have the formula R is equals to V divided by I. V is the voltage across each lamp, the voltage of the each lamp that is marked it's 12, and I is the current 3, so 12 divided by 3 that's equal to 4 ohms. The combined resistance of two lamps when they are connected in parallel. So each lamp is having a resistance of 4 ohm as we calculated, and they are connected in parallel. So if they are connected in parallel, what is the combined resistance? The total resistance. So it is product divided by sum when two components are connected in parallel. So 4 multiplied by 4 divided by 4 plus 4. So 4 multiplied by 4 is 16 and 4 plus 4 is 8. So 16 divided by 8 that's equal to 2 ohm. So 2 ohm is a combined resistance of these two lamps which are connected in parallel to each other. The energy used by one lamp in 30 seconds. So how to get the energy? Energy is voltage into current into time. So voltage across each lamp, that is 12, multiplied by current in each lamp we calculated, that is 3, multiplied by time, so 30. So 12 multiplied by 3, that is the power 36, and 36 multiplied by time 30 seconds, so it will be 1080 joules is the energy consumed by each lamp. So figure 8.1 is a plan of a small apartment that has 4 lamps. So the power of the lamp is supplied at 200 volt AC and the lamps are all in parallel. In a space below, draw a lightning circuit so that there is one switch for each lamp and one switch for each room and one master switch that will turn on and off all the lamps. And the label the lamps as 60 watt and 100 watt. So in a living room, there are two lamps in the living room and they all are connected in parallel. So, like example, these are the lamps in the living room. Then there is a lamp in the kitchen and another lamp is there in a bathroom. So each room is having a single switch, one switch. So means the two lamps which are there in a living room should have a common switch. So how to draw a common switch? And there's a supply here. I can connect a AC supply that. So this is a symbol for AC supply. Now there's a common switch for these two lamps in the living room. So these two lamps in the living room must have a common switch. So we make a common switch. Then as all the lamps are connected in parallel and each room, like example, this is a lamp in the kitchen and this one is a lamp in the bathroom, and label each lamp, like example, lamp in the bathroom is 60 watt, in the kitchen it is 100 watt, and in living room there are two 60-watt lamps, and they are all connected in parallel. So parallel means they will work independently or separate connection for each lamp from the battery. And there is a one master switch. Master switch means the switch should be there which can turn on and off all the lamps. So master switch is always next to the supply. So this is how the circuit should appear, that this is a 200 volt AC supply is there. So 200 volt AC supply with the master switch, a switch which can turn and off and on these all the lamps together. Then one switch for the living room, one switch for the kitchen, and one switch is there for bathroom. And label each lamp because in the living room there are two lamps, so they have a common switch. Then in a kitchen there is only one lamp with a switch, and in a bathroom as well, one lamp with a switch. So this is how you should draw a circuit according to the information given above. Then a 100-watt lamp is switched on, calculate the current. So how to get the current? Because as we know, they are all parallel. So if they are all parallel, they will receive the same voltage. So if this is 200 volts, what will be the voltage across each lamp? This will be 200, 200, 200, and also 200. So each lamp will receive 200 volt and power is 60. Your power is 100. So we have the formula P is equals to VI. So power is 100 and the voltage across each lamp is 200 multiplied by current I. So 200 is multiplied, other side will be divided. So 100 divided by 200 is I and 100 divided by 200 is 0.5 ampere. The charge passing through the lamp in 1 minute. So we have the formula current is equals to charge divided by time. The current in this lamp, 100-watt lamp, is 0.5. Charge we don't know, and the time should always be in seconds. So 1 minute means 60 seconds. So this is 60. 60 is divided. Other side it will be multiplied. So 0.5 multiplied by 60. The charge which will pass through each lamp is equals to 30 coulombs. Then 360-watt lamps are replaced by 3 energy saving ones which are only 15 watt. Calculate the total reduction in power. So 360-watt lamps. So what is the total power reduction? If we are using a 60-watt lamps, what is the total power we are using? So it will be 60 multiplied by 3, which is equals to 180 watt. That which we were using before. But now we replace by 15 watts. So 15 multiplied by 3, that's equal to 45 watt. So how much reduction in the power, how much power has reduced? So before we were using 180-watt lamps total power of 180, but now we are using only 45. So 180 minus 45, so that's equal to 135 watts. That's a total reduction in the power. Then energy saved when the lamp lit for 1 hour. So how this is a power which we save. Now we need the energy saved. So energy is equals to power multiplied by time. The power of each lamp is 135. The power which we save is 135 and the time is 1 hour. So it means 16 to 60 because the time should always be in second. So it will be 60 multiplied by 60. So 3600. So 3600 multiplied by 135, that will give us about 486,000, or we can also say 4.8 into 10 to the power 5 joules. So this is how much energy is being saved when we replace the 360-watt lamps by 15-watt lamps each. Then the circuit shown in figure 10.1 uses a 12-volt battery. So look, the two lamps are connected in series. A and B are identical lamp. Each are designed to work for 6 volts. So this is a 12-volt supply. Two lamps are connected in parallel, so series, sorry. So this will receive 6 volt. This is also because they have the same resistance. If the two lamps have the same resistance, the equal voltage will drop across them. Then the switch S is open. State the value of a potential across S1. So across the open switch, the voltage is same as the voltage of a supply whenever switch is open. So if the voltage of a supply is 12, how much voltage will be there across open switch? That will be 12. Reading on the voltmeter, because across all the voltage drop across the open switch, so that because the switch is open, there is no current in the circuit, so there is no voltage drop across the lamp. So the voltage across, there is no voltage drop or energy consumed by the lamp. That's why what we say the reading on the voltmeter will be 0. So whenever, remember, you have an open switch, like we have a supply, if we have example only one lamp was there and we have open switch, so if it's a 6 volt supply, because the switch is open, so there is no current. If there is no current, lamp will be off. If the lamp is off, what is the voltage across the lamp? 0. So the remaining, the total voltage across the switch is same as the voltage of a supply, so it will be 6. But once the switch is closed, now what happened? There will be 0 volt across the switch and all the voltage will be there across the lamp, because the lamp now start to work as there is a current in the circuit. So when the charges start to flow, there is a current in the circuit. The voltage of the lamp will be same as the voltage of supply now. So same thing happen here. If we have an open switch, so there is no current. If there is no current, the lamps will be off. If the lamps are off, what is the voltage across these lamps? The voltage will be 0, or no potential difference across the lamp, and all the voltage will be there across the switch. Once the switch is closed, so if the switch S is closed here or connected, now what happened? Because now the charges start to flow, there will be a current in the circuit. As a result, when there is a current in the circuit, so the lamp will start to work, and because these two lamps are connected in series, this is a total of 12 volt, and they have the same resistance, so they will have the same voltage, like the total voltage divide equally between the two lamps, so they will receive 6 volts each. So the first part, when they ask when the switch is open, so if switch is open, the lamps are off. So when the lamps are off, what is the voltage across the lamp? 0. So all the voltage is actually across the open switch. So this is 12 volt and this one is 0. The voltmeter reading. Comment on the brightness of the lamp. So when the switch is open, both lamps will be off. So they will not light up. If they don't light up, they will not give out any light or no brightness. Now the switch is closed. Closed switch means it is connected. So when we say a switch is closed, it means switch is connected. But if we say switch is open, it means it is not connected. Now state the new reading on the voltmeter. So as I mentioned, when this switch is connected, the current start to flow, and because the two lamps have the same resistance, so they will have the total voltage, which is a 12, will divide evenly between the two lamps, so it will be 6 volts across each lamp. So the voltmeter reading will be 6 volt because the voltmeter is connected in parallel. So the new voltmeter reading is 6, and comment on the brightness of the two lamps. So they will light up and they will have the same brightness. Under these conditions, each lamp has a resistance of 18. Calculate the current in each lamp. So how to calculate a current in each lamp? We know the voltage is 6. So formula V is equals to IR. V is the voltage, that is 6. I is the current and R is the resistance 18. So it will be 6 divided by 18. That is the current in each lamp. So 6 divided by 18 will give us 0.33 ampere. Now with the switch open, the lamp are now connected in parallel with a lamp A with no current, and each lamp has a resistance of 1.8. So now new lamps are there which are connected in parallel. 1.8 ohm is the resistance for each lamp. Calculate the value of combined resistance. So if we have two lamps, each of resistance 1.8 ohm, and they are connected in parallel, we want to find the combined, so it will be product divided by sum. So 1.8 into 1.8 divided by 1.8 plus 1.8. So product divided by sum. So 1.8 times 1.8, that is a product, which is 3.24, divided by sum 1.8 plus 1.8, which is 3.6. So 3.24 divided by 3.6, that's equal to 0.9 ohms. So whenever two lamps are connected in parallel, the combined resistance will decrease. Then they are saying state why it should not be wise to close the switch when they are connected in parallel. So why we should not close the switch here when we connect them in parallel, like we have a 12-volt supply. Why we should not close the switch? Because what happen if we close the switch, the circuit is having a low resistance, so it will have a very high current. As the two are connected, the circuit resistance is low. So if the circuit resistance is low, it will have a high current. And if it is having a high current, that current can like produce greater heating effect, or it can melt the filament of the bulb. So even this too high current can melt this filament, and so the two lamps will blow, or the filament of these two lamps will blow due to the high current. So whenever circuits have low resistance, they will have high current, because the resistance is a property of a material or a circuit to resist the flow of the charges or reduce the current. So if low resistance means it will have a high current, so greater chance is there that it will produce a greater heating effect, which can blow the fuse, or it can melt the fuse as well. So for electricity, the important thing is that you learn the formulas. Once you learn the formula and you have an understanding of a circuit, then you can solve question related to electricity. Now the circuit 4.1 is a small immersion heater is there, which is a 6 volt. State the name of component X. So what is this component X? This is actually a variable resistor. And what is the purpose of variable resistor? It is used to change the current or the voltage in the circuit. By changing the resistance, we can use it to change the current or voltage of the circuit. The next part, the heater is designed to work from a 3.6 volt supply and a power of 4.5. Calculate the current. So how we have the power of the heater, and we have the voltage here. This is a voltage, and 4.5 is the power. So P is equals to VI. 4.5, V is the voltage, which is 3.6, and I is the current. So it is 4.5 divided by 3.6. So 4.5 divided by 3.6, that's equal to 1.25. So 1.25 ampere is a current which is passing through the heater. And because the heater, so 1.25 is the current which is passing through the heater as the switch is closed. So it means 1.25 here. So same one, because they are in series, so same 1.25. Say 1.25 will return and 1.25 enter the circuit. And they mention the voltage across the heater is how much? The voltage is 3.6. So they are connected in series. Whenever two components are connected in series, the voltage will divide. If the total is 6 out of 6, if 3.6 is dropped here, so 3 minus 3.6, how much voltage will be there across this component? It will be 2.4. So 2.4 volts will be there, the voltage, because the voltage divide in series and the current is same. So current is 1.25 and the voltage is 2.4, because the next part they asked to calculate the resistance. So how to get the resistance? As we use the circuit, so resistance is voltage divided by current. The voltage is 2.4, which is the remaining voltage, and the resistance, the current is 1.25. So 2.4 divided by 1.25, that will give us 1.92 ohms. So 1.92 ohms is the resistance of this component X. Sometime after the heater is switched on, the ammeter reading have decreased. What is the reason for that? As we know, the resistance and temperature are directly proportional for fixed for conductor. So as the temperature increase, as I mentioned, after some time when a heater is switched on, so what will happen? The temperature will increase. So as a result, there is an increase in temperature. What will happen? The resistance of the circuit will increase. And when the resistance of a circuit increase, what happened to the current? The current will decrease. That's why the ammeter reading decreases, because the temperature of the circuit increase. So the resistance of a circuit increase, which cause a decrease in the ammeter reading or the current in the circuit.